Hello everyone, Saidu here. Welcome to another CCNA Cybeops Lab. In this lab, I will be showing you Linux file system in general, and we get to explore the file system and view some of the file system that are mounted currently on this machine, as well as some of the commands that are associated with the file system, like the list block or the umount or mount command and all that. So just the basic of the file system. Now the other part of this lab will be the Linux file permission. So we'll get to check out the file permission on each file as well as the directory. So we'll get to even change the ownership of the file or change the permission on a particular file or a directory. And the final part will see the symbolic link as well as some of the special files in Linux. So with that being said, let's get started. First, I'm on my CCNA Cybeops workstation now. I'm on the command prompt. So basically, what is a file system? File system simply means the way or the structure of data that are saved or stored in your machine, as well as the way you retrieve them. So in essence, you can say a file system controls how it's stored and retrieved. So the Linux file system support many different types of file system. So, but in this particular lab, we are going to see the ext file family, or you simply say the extended family file system. So any file system must be mounted before it can be used or can be accessed. So basically what mounting file system is a kind of process of linking the physical partition on the block device like the hard disk or SSD or pen drive etc to a directory. It's just the way of allowing the file to be accessed by the operating system. So before that, let me list the block like the hard disk on this device. I'll use this command, the lsblk, this block. So right now we can see that we have like 6 block devices here on this machine. We have the SR0, we have the SDA, and we have the SDB. So as well as SR0, we have the SDA, and we have the SDB. So as well as the file size or the storage space on this particular partition. So each of these block device, like the SDA, has one partition each. This one is SDA1, and this one is SDB1. So we get to see the file, the storage space on each device. So now, how do we even know the file system that are mounted on this device? So the command that we use to check that is simply mount. So you can just use mount from your command prompt and hit enter. This will show you all the file system that are mounted on this particular machine. So right now, most of these files we don't have business with them. We don't really need them. But the one that I'll be showing you here is this. If you remember, the block that we just view is we have the SDA1. So basically what this means, or let me just bring it so that it will be more readable here. I'll use the grep command to bring it down or to just view it as single. Use the mount command, then mount, and then here say grep, then SDA1. So this will show me the single SDA file system here. So here we have something like this. So by convention, this is how a Linux store the file or the block. So you have the dev or /dev /SDA1. Now depending on the partition, so this one might be something different. It might be SDB like the one we saw earlier. The other one is SDB, the other. So by convention, the /dev /SD is what you have. So the A or the number there is simply it can it can change to anything. So if for example somebody is say 4 block of devices, so this could be SDA, SDB, SDC, SDD, something like that. So how do we read this? Now the file system that are stored here on this particular block device is the operating system. So these are like the root file system that are stored. Why I know that is because of this slash here. So look at this, say /dev /SDA on this. On this slash simply means the root file system. So and the root file system is where the operating system and other configuration files are stored, other command and tools like that. So the file type is ext4. So like I said, we will be focusing on this ext or the extended. So this one is the fourth one, or the fourth version. And this one in parentheses simply means the options. So you have RW, which stand for read and other stuff. Now let's go to the root directory. So you can do that using just by saying cd then slash. This will take you directly to the root. Now we are on the root directory. So list or ls dash l to view the content of this directory. So this is what we have in this root directory. So if you remember, when we are talking about, or when I view this here, right here, when I list the block devices, we only see the SDA, and we saw of 3 blocks. So, but when I check back here, like check the currently mounted devices or file system, we couldn't find the SDB. So that is because the SDB is not, or was not mounted on this particular machine, the file system. So now I'll go back to my cyber or analyst user, say cd to this, and list the content using the ls-l to get this. Now here you find something. If you are using your CCNA Cybeops workstation, you should be able to see the second drive. So, but if you don't have it, you can simply make it using the mkdir make directory. Say mkdir, then you enter the name as second, second drive. So you have something like this. So this will not be created, as it will say that the second drive has already been created. So it cannot create a directory like that. So here, what I'm going to do now is to mount this. So first, let me view the content of this second drive. Say list s second drive. Now here, currently this drive is super empty. They say it is super empty. They say the total is 0. So what I'm going to do now is to mount that SDB onto this drive and see what will happen with the content. So doing the mounting is simply using the command sudo mount. Then you enter the say dev as SDB1. Then you enter the destination, which is second drive, in our own case second drive. So I'll enter the password CyberOps, and if I am to check, say ls dash l second drive, should be able to find something there. Now look at, we have some files that are in the second drive. So initially, before the mount, we don't have anything. We have the total of 0, and now we have some files registered there. So if I'm to check the SDB, say mount grep. Let me just pipe this to SD. Yeah, grep. Let me just pipe this to SD. Yeah, SD. So we'll get to see the file system that are mounted currently. So we have the dev SDA1 and the dev SDB here. Have them all. Now this one, this is the part on which it is being mounted, and this one, the dev SDB1, is being mounted on this drive. So we have 2 mounted device. So how do we unmount? Say for example, you don't want this, you don't want it to be mounted to that particular partition. So how you do that is simple. You just simply use the opposite of the mount command, which is the unmount, but you don't spell it out unmount. You only use umount to specify that you want to unmount the file. So use umount, say umount, and then dev sd. So umount dev sdb1. Or first, let me use the sudo sdb1 dev slash sdb1 should mount it. So now if I check the content of the second drive, should be now empty. So look at, I have successfully unmount that drive or that file system from the second drive. So if I get to, okay, right, now let's talk about the file permission. Now Linux do have a permission to each file or directory depending on the permission assigned to that particular file. That is what the user will be able to do. For example, if the analyst user was given the permission of read, that is the only thing he or she will be able to do on that particular file or directory. So if, for example, the permission has been elevated maybe from read to read write, meaning you can read and you can also write to the file. So that will give you the permission of reading and writing to that particular file. But how do we even find these permissions? How do we even list them? How do we even know the type of permission that are assigned to a particular file or particular directory? We can do that using simply let's first go to a cd lab support.file. Say from here cd lab the support.file. Now from this directory I'll try to list out things. Say ls-l ls-l. So we have a bunch of files here, and we also have some directories. So but the one I'm going to highlight here is this. We have something like this. So from here, the file permission is read write. The first one is read write, which is simply saying that the owner of the file, which is the analyst, can read and write to this particular file, and then members of the group can also read, but they can't write to here. This is the owner, and this is the group of the owner. So the owner can read and write. The members of the group can only read, and then other can also read, but they cannot write. So the only user that can write to this particular file is the owner, which is the analyst. So that is how you read a file permission from Linux command line. So, but for example, let's try to create a simple text file. So you can do that using, let's say, let me go to this folder, say script. So I'm here now on this directory script. So here I would try it out creating a file called a simple text file called using this touch mn, and then my new file .txt. Okay, so here what having is that a message from touch say what I'm having is that a message from touch say cannot touch this mnt new file text, say permission denied. So we don't have any permission to create a file here on this script directory. So we don't have the permission, but to check the permissions on this directory, on the mnt directory, how do we do that? We just simply say ls ldb. Say so. Now what we are seeing now, it is that this particular amount or mnt directory, it belongs to the root user and from the root group, but I am logged in as analyst, so I don't have the permission or the privilege to create file on this directory. So analyst user is not having any permission to create this. So look at the only user, which is the root, is the owner of the directory. Maybe users from the root directory can order from it the file. So now what it means is for me to create that file, I need to use the sudo command. So but if either I use the sudo command or I will change the permission from that. Let's say from now, instead of using the sudo command, but what I would do now is to change the permission entirely so that I'll be able to create that file or that new text file. So what I'm going to do now is I'll mount the SDV, the SDB one that we initially unmounted. Now I'll mount it to the same file, the second drive here. Say use sudo mount. Then I'll enter the dev SDB1, the dev SDB1. Then enter this. Then the second drive. This is where I want to mount the SDB1. So enter the password of CyberOps here. So now if I list, say ls-l. Okay, I have to go to the second drive first and see the second drive. So ls-l. So this is what I'm having now. So I have this example, say analyst, a file created by analyst or the owner of analyst, meaning this file here, my file.txt, is a file that analyst user own. For example, here, this is the owner of the file, analyst, and this is the group of the user or the owner, analyst group. So what I will try to do now is to change the permission of that particular file. So, but before then, the current permission on this file, this one, the first one is read write, meaning the owner can read and write to the file, and then the members of the group can also read and write to the file, and the others can only read. So I'm going to use the change mode command or the ch mode command to change the permission. So that one is easy. The way you do it is you simply use the sudo command, say sudo, then you bring your command ch mode, and then you enter the numbers, say 5 dash my file.txt. So these numbers, these 665 are simply numbers that represent permission. For example, they are in octal, so 6 here is 110. So what 110 means is you can read, you can write, but you cannot execute. So that is what the 110 means. So if you have a number like 101, it means that you can read, you cannot write, but you can execute. So that is how the file. But we'll talk about this permission in details some other time. So if, for example, you want to assign you want to assign all permission to that particular file, like to change it to want to assign all permission to that particular file, like to change it to read, write, execute, everything can be done on that particular file. You simply use 777 instead of 66. So now I'll go ahead and hit enter from my keyboard. So if I am to check the content of the file now, it should have changed it to, let's say, let me see, I think, yeah, ls this. So this is how you change the file. I know maybe it doesn't show much here, but we'll see that in a bit. So what if you want to change the owner of the particular file? You want to change it from analyst to something else. You want to change it maybe from analyst to root. So you can do that. You can do that. So here I will just use the command say change ownership. So you simply use say sudo ch then own, then you specify the user that you want to own this particular file. So right now mine is analyst. So I'll change it to, let's say, root, and then the name of the file, say my file, this file now. Look at the root user, or now this file belongs to the root. So you can do that to the group. So for example, if you want to change the user or the owner of the file as well as the group of the owner, you can do that using one straight command or one straight line. So you can just say sudo then sudo change ownership to, let's say, root then colon root and then the name of the file, which is my file.txt. So if I check the content now, should be able to see that the root user is the owner of this file, and the root group is the root, or the user group is the root group. So that is how you change the ownership from one user to the other, change the ownership of a particular file or directory. So now I would test out something or simple cat. I'll just say echo how to append to a particular file. So now I'll just say echo test, then I'll do txt. So what I'm doing now is simply appending to the myfile.txt. So if I check now, say bash myfile permission denied. So I've changed it because I've changed the user to root. So maybe I have to use the sudo. Say sudo permission denied. Okay, maybe let me change it to the analyst. Change this user to analyst, and then change the group to also analyst. So let me check the content now. All right, that's been changed. So test it. Okay, now it's going. So the TS I wanted to spell test here. So but don't mind. Just use the cat command to view the content of my file.txt. Cat my file.txt, and then look at I have something like this. So this is the one that I did previously. But here, this is the one that I just entered, TESR. So that is how you append to a particular file. So what about the directory and permissions? So the directories do have their own permission, just like to a particular file. So what about the directory and permissions? So the directories do have their own permission, just like in the case of the file. It's kind of simple or the same in a way, because you get to see the read write or the execute, something like that. So but one of the key difference between a file and a directory, you can always check that. Let me go back to, say, cd, no, cd and lab source file. So now ls -l. Now, one of the key difference between a file and a directory is this. So if it is a file, you get to see that the D or letter D is the first letter that you'll be seeing on this permission section. So you see the D, which represent a directory. So if it is a file, you simply see this dash or minus sign. You see it here to just tell you that this is a file not a directory. So that is one of the key difference between what we'll be comparing here is the permission between the, say, the malware and the mainnet service. So if you check this, you see that they are quite different. So this is a folder. The first one is a directory, and then the second one is not a directory but a readable file. So that is one of the difference. So here, this one is having the rwxr, this one is having dash rwxr, stuff like that. So that is how you differentiate between a file and a directory. So let's quickly check about the symbolic links. Now, symbolic links are simply a kind of shortcut on Windows. So you get to create a different kind of symbolic link because you have two types in Linux. You have the soft symbolic link, or you have the hard link. The soft symbolic link, that is the perfect description of a shortcut on Windows. And another thing to pay attention is this. So if you have something like because the first letter always tells you what type of file it is, tells you what type of file it is. So if you have this, let's say the dash here, for example, this particular file or the first file here, it's just a regular file. So this regular file can be a text file, can be a program, it can be image file, it can also be a compressed file. So the D, the one that starts with the letter D, is just a directory. So other special files can include the B, the letter B, or letter C, or you see some with letter L. So we get to see how to use the letter L. The letter L is simply a way of saying that this is a symbolic link or a shortcut to a particular file. So the symbolic link point to a particular file, but just like the way shortcut works on Windows machine. So you have your shortcut that points to the original file or original program. So that is that. So let me say cd. Now this is the some of example of some of the files. So here point are all directory listed, and then here a text file. So that is why we see them like this, just like regular file. So but let me check the listing of, let's say, ls-l/div. You have this. So you see these are a bunch of the files that we talk about here. You see some files that even start with the C, meaning that they are a compressed file. So you have this link. The one that starts with L is a symbolic link. So here we have much other ones. So the D is here, which is a directory, and then the C compressed, and then this one L is that symbolic link. So I think that is all we have here. So that is how to quickly check or define or know what a particular file is and what type of file is that in from Linux command line. So but let me try to check if I can make a symbolic link quickly. So from here I'll just say echo, then my double quote, enter symbolic, then use this red sign up here, and then file.txt. So if I check my file.txt, I should be able to see this, what I just wrote, symbolic. Look at it here. So that is my file.txt. So, but let me go ahead and create another one, say echo, my double quote, and then here, instead of symbolic, I would simply write enter. On this one here, and name this file2.txt. So that is that. So if I'm to check this card file txt, I should have something like this as had. So how to make this a symbolic link, or how to create a symbolic link out of this? You simply use, let's say, link, or you say ln-s, then file1. For example, we want to make the file1 a symbolic link, and then now type the shortcut name or a symbolic link name. Say symbolic. So that is that. So let me make the other one, say link file2. So when you are making a hard symbolic link, you don't need to use the dash s. So you use the dash s to simply specify that you are using, or you want to make a simple soft symbolic link. txt, and then file2 hard, then add. So that is that. That is how to create the symbolic link. The content now, I should be able to see them both. So look at this is the symbolic link, the soft one. We have this, and look at the file. That's the way it start with the it start with the L to see specify that it is what it is, a symbolic link. So if I check this here, I'll see that this one is simply the same thing as the original. Everything is the same. So this is the original file, and this is the symbolic link. So here I find out that the hard link is a kind of carbon copy of the original file, whereas the soft symbolic link, it actually points to the original file. So that is how you create a symbolic link. So now what I'll try to do is to see if changing the name of a particular file will affect its link. So what I'll do here, I'll just say env for move file one, no, file one dot txt dot txt, file one dot txt dot txt, file one dot txt, then and then I'll say I want it to be now named as file one new.txt, and then I'm getting an error. Move file one.txt. What happened? Saying that I don't have it. So okay, let me check this. Say move, say mv dash l. Then I have, okay. Say mv file.txt file. Okay. Move file two add file two.txt, and then name it to file 2 new.txt. So here I'll just simply say cat and file 1 symbolic. So right now, okay, file 1 symbolic. So file 1 symbolic, say no such file or directory on this machine. Why? Because by changing the name, it's now result to something different. It is a soft link. So if you change the original, do not be accessible. So, but if I check the hard one, which file to hard, now I'm still seeing the content of the file, because it is like it's the same thing. It's just like having two different files, but they are having the same content. So that is how. So use this as a kind of stepping stone and practice to know how to use this Linux file system. Use the command mount or umount to mount a particular file system. Use symbolic link, or use the file permission to check the permission of a file. Change the ownership, change the permission, and just play around with this simple lab, and I will see you in the next one. Thanks for watching.